A sample of 23 newborns at the Dallas University Health Center had the following lengths in centimeters. The measurements have been sorted from lowest to highest already, so that's nice. Find the 5-number summary of the lengths of the newborns. So that includes the minimum, the maximum, the median, Q1, which is the first quartile, and Q3, which is the third quartile. So, in order to find the median, first I'm going to cross off. So right there, and first and last. Second, second to last. Third, third to last. Fourth, fourth to last. Let's see, is there one right there? No. So the median is 50.4. And then Q1 is going to be this half of the data. I need to find the median of that. So I'll cross the other way. It's right there, 48.5, that's Q1. And then the third quartile is using this data. And we're left with 52.5. The minimum is 46.4 and the maximum is 55.9. Create a box plot for this data. So I have everything that I need to make the box plot. First I'm going to make a scale. So let's see, I need to go from 45 all the way up to 60. So maybe I'll just go from 40 to 60. Let's see, 50 is in the middle. So then 45, and then that's 55. So my median is 50.4, that's right a little bit above 50. Maximum is 55, or Q3 is 52.5, so that's halfway in between 50 and 55. And Q1 is 48.5. So there's that. The maximum is 55.9, and then the minimum is 46.4. So there's a box plot for that data. Number 2 says match the histogram to its corresponding box plot. Alright, so the first thing that I notice is I want to look for data that's relatively, let's see, I'm going to open this up. Okay. So the first thing I'm going to look for is some data that's really close together, because this one, all the data is really close together. It's not very spread out. So I'm going to take this, I'm going to say that these go together, these match, because the data is all clustered together right here in the middle. I notice that this one has one outlier that's way ahead of everything else, and that the median is kind of closer to the middle. Closer to the left side. So when I look at my box plots, I see that this is the only one that has one little bit of data that's way ahead of everything else. Every other one on the right side, they have lots of data. So I'm going to say that A matches all the way over here because of that one little outlier. Alright, now if I look at, let's see, I see that this data is really skewed to the right. There's a lot more data here on the right side. So that tells me that the maximum and the Q3 and the median are going to be really close together because they're all going to be in this right side of the data. And then we've got some random points all the way out here on the left side. So I see that this box plot is skewed to the right side. So I'm going to connect these two. So now I've got left C and D, and I've got these two box plots. So let's see, what do I think? In this one, the data is pretty symmetrical. In both of them, actually, the data is pretty symmetrical because it's not skewed to one side or the other. This one's kind of evenly skewed to both sides, so it's still symmetrical. And let's look at the middle 50% of the data, because that's where the boxes are. So the middle 50% of the data, let's see, this is hard to think about. It's hard to decide between these two. So I think that in part D, the middle 50% of the data, because the data in the middle there's smaller amounts of data in the middle, to get a middle 50%, it's going to be more spread out. So the middle 50% is going to be more spread out in box D. So that would match with this plot. And in box C, the middle 50% of the data is going to be less spread out. So it would match with box 5. So explain how you matched box plot A. So to match box plot A, what we did was we looked at the outlier. So I saw that box plot A, this should say histogram. I saw that box plot 4 had an outlier. So I looked for a histogram that had one data point on the far right. Explain how you matched box plot C. So this should say histogram. So to match histogram C, we noticed that the data was pretty symmetrical. So I noticed that the data was pretty symmetrical. So the box plot would be symmetrical. Also, the middle would be more condensed. So the middle 50% of the data would be less spread out than histogram D, than in histogram D. Alright, number 3 says solve the following quadratic equations using any method. So zero product property, graphing, completing the square, etc. So the first thing I notice on this one is that it's got really big numbers, but that they're also divisible by 4. So I'm going to divide by 4 on both sides. So if I divide 10,000 by 4, I get, so if I divide everything by 4, then I get 2,500 x squared minus 16, because 64 divided by 4 is 16, equals 0. So I just made my problem a little bit easier. And I think I can actually divide by 4 again. So 2,500, oh wait, maybe that doesn't divide by 4. Oh yeah, it does. 625 x squared minus 4 equals 0. So I'm going to try to factor this by using a box and a diamond first. So in my box, I'm going to get 625 x squared, and in here I'll get negative 4. In my diamond, I multiply to make the top, so 625 times 4 is 2,500. And then they have to add up to 0, because I have no x term in here. So they have to add up to 0. So they multiply to 2,500 x squared and add to 0. So I know that if they add up to 0, it's going to be the same number, one positive and one negative. So what number multiplies to 2,500? And I think that it's 50. 50 times 50 is 2,500. So I know here I'm going to have positive 50 and negative 50. So I get 50x and negative 50x. So here to get 625, let's see, 50 is not divisible by 2. So I'm going to pull out a 2 here, and I get negative 2 here and positive 2 there. And negative 2 times 2 is negative 4. And then 25 would be left over, so 25x. And then 25x. So I get 25x plus 2 times 25x minus 2 equals 0. And then I use the zero product property. 25x plus 2 equals 0. 25x minus 2 equals 0. So we get x equals negative 2 over 25, or x equals positive 2 over 25. So those are our two answers. For this one, I notice that it's not in ax squared plus bx plus c, so I'm going to put it that way. 9x squared plus 34x, because I'm going to move it over to the other side, minus 8 equals 0. Here, I don't see any common factors. I'm not going to try to factor it. I'm going to use the quadratic formula. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I know that a equals 9, b equals 34, and c equals negative 8. So I get x equals negative 34 plus or minus the square root of 34 squared minus 4 times 9 times negative 8, all divided by 2 times 9, which is the square root of 34 is 1,156, and then this will be plus 4 times 9 times 8, 288, all divided by 18. That equals negative 34 plus or minus the square root of plus 288, 1,444, all divided by 18. So that's negative 34 plus or minus the square root of 1,144 is 38, all divided by 18. So we get negative 34 plus 38 over 18. X equals negative 34 minus 38 over 18. So we do that math, and this would be 4 divided by 18. Which is 0.22. This one would be 34 plus 38. Negative 72 divided by 18, which I believe is 6. 72 divided by 18, it's 4. So it equals negative 4. So our two answers are 0.22 and negative 4. Write and solve an equation or system of equations for the situation described below. Be sure to define your variables and show all work. That should say show. Daria has 18 coins that are all nickels and quarters. The number of nickels is 3 more than twice the number of quarters. If she has 190 in all, how many nickels does she have? So we're trying to find out nickels and quarters. So I'm going to let n equal number of nickels and let q equal number of quarters. I know she has 18 coins. So the number of nickels plus the number of quarters has to equal 18. The number of nickels is 3 more than. So the number of nickels is equals 3 more than. So that's plus 3 twice the number of quarters. So twice q, twice quarters plus 3 equals nickels. So I'm going to use substitution since I have n by itself. I'm going to substitute that in right there. So I get 2q plus 3 plus q equals 18. 2q plus q is 3q. And then I'll subtract 3. 3q equals 15. Divide by 3. Q equals 5. So she has 5 quarters. That's not asking us what it wants. How many nickels does she have? So if she has 5 quarters, and we know she has 18 total, then she must have 13 nickels.